Okay, when you multiply or divide by a negative number, what do you do to the inequality sign? Flip it. Okay. Algebra 1 old way. How do I graph x is less than 3? From those people that remember Algebra 1, from 10 years ago. How do I graph x is less than 3? Yeah, you put the number that x is in the inequality, and you put 1 greater and 1 less. Okay, and then you used to do what? Put a little circle around 3. Now, is that an open circle or closed circle? Open, because there's no equal sign, right? And then you would either put an arrow going this way or you would shade it. Either way, right? Okay, that's Algebra 1. Algebra 2, you're going to, instead of circles, you're going to do what? Yeah, triangles. You're going to use this little chart over here. And instead of circles, you're going to use either parentheses or brackets. Notice the brackets is your closed circle and your parentheses is your open circle, right? Brackets if it includes an equal sign. Okay, so what do we have here? A bracket or a parenthesis. We have a parenthesis at 3, and the inequality, it's read less than, so we're going to put the parenthesis going less than. This is going to be, what, negative infinity over here? And this is going to be positive infinity. So you can either shade or, yeah, let's just shade. I'll do it the same. Okay, so there's my answer graphing. Yes, sir. Can you, yeah, I guess so. All right, now another new thing here is we're going to use interval notation. Interval notation. Okay, we're big algebra kids now. All right, so we're going to put our least number first. What's our least number in our graph representation? Negative infinity. That's our smallest number being represented in our graph. Now, am I going to put a parenthesis there or a bracket? Parenthesis, because we can never reach negative infinity, so we can't include that point. What's my largest number represented in this graph? 3. Does 3 get a parenthesis or a bracket? Well, it obviously gets a parenthesis because we put one in our graph. We do not include the number 3. And voila, that's how you do it in Algebra 2. What about the second one there? X is greater than negative 2. Well, we're going to put our negative 2 in the middle, and I want a number greater than negative 2. Negative. Martin, what's greater than negative 2? Good. Remember, negative greater number is actually the number smaller. A what? I don't care. You don't understand that. I don't care about that. Okay, one number greater, -3. Okay, so at number -2, do I put a bracket there? Bracket, and my inequality is pointing that way because my variable's on the left-hand side. So my bracket is going to point that way. And I'm going to shade all of those numbers that are greater than -2. So my interval notation is my least number, which is -2, and it has a bracket, to positive infinity is my greatest number. Infinities always get a parenthesis. It's just too easy, Mr. D. Can't we do something hard for a change? Not yet. All right, let's do some solving inequalities and then graph them. Let's do all of them. If you want, you could actually go ahead and put your dotted line in there. I have to isolate the variable, just like an equation. So what am I going to do first here? Your choice. I'm going to add 8 to both sides because it's my choice. So I get 5y we added, so nothing, the sign stays the same. 12 plus 8 is 20. Gonna divide by 5. Do I have to flip the sign? No, because I'm dividing by a positive 5. Even if that was a -20, I'm dividing by a positive number, so I would still not flip the sign. So y is less than 4. Okay, graphing. I'm gonna put my 4 in the middle. I like using one bigger, one smaller. By the way, you don't have to use the next number. We want all of those. Do we include 4? No, we do not. There's no equal sign. So I'm going to use a parenthesis, and I'm going to aim it this way because that's the way of my inequality, and it's going towards -infinity. So my interval notation, my smallest number is -infinity, always gets the parenthesis. My largest number, 4, and I'm just going to take that parenthesis off the graph. Easy, right? Mr. D, when are you going to stop giving us easy stuff? No. Not yet. Almost. Almost. The entire first unit is. There's 3 units in semester 1. So a third of the way of the school year is reviewed. Okay, subtract 5 from both sides. Bring down the -2 x. I subtracted 5, so my sign stays the same. 27 minus 5 is 22. Divide by the coefficient, -2. Wow. -2's cancel out to 1. 1 times x is x. 22 divided by -2, I get -11. What happens to my inequality sign? It flips because we divided by a negative number. Okay, negative 11, one larger, negative 10, one smaller, negative 12. Let's see, I have an equal sign with my negative 11, so I'm going to use a bracket. And I want all of those numbers less than negative 11, or follow the inequality sign because my variable's on the left-hand side. Interval notation. My smallest number represented in this graph is negative infinity, always gets a parenthesis. My largest number represented in this graph is negative 11, and it gets a bracket because it's included in my answer. It's just, it's insulting how easy it is, isn't it? Nice language. Okay, let's do one more of these. You have to, in this one, because we have a fractional coefficient, the easiest way to do this is to add 7 to both sides first. 7 add up to 0. I get my 3 halves x greater than 9. What's the easiest way to get rid of a fractional coefficient? You want to multiply by 2, then divide by 3, that's fine. Or you could just multiply by 2/3. Reciprocal. These cancel 1. 1 times x is x. Hey, 2/3 times 9. If you break 9 down into thirds, it's 3 times, there's 3 threes, right? 2 of those threes is 6. Or, if I were you guys, I'd plug it into my calculators and get 6. Okay, 6 goes in the middle. 1 larger. 7. 1 smaller. 5. I have a bracket, and I'm going to follow the arrow because my variable's on the left-hand side. I'm going to use a parenthesis, no equal sign. And I want all of those numbers greater than 6. So my interval notation, the least number represented in this graph is 6, not including it. And the greatest number is infinity, not going to include that. Should we do just a little bit harder? Is it confusing?
Where I do it.
Come on, you guys are blind. Yeah, you are. I don't trust you.
Where I.
Okay, number 5. We remember we have to have the variable on one side and everything else on the other, right? Okay, the first thing I'm going to do here is distribute the 4. So, stop laughing, it's not funny. So I have 5 minus 5x greater than or equal to 4 times 3. 12, 4 times negative x, negative 4. Now, normally I would say, hey, let's add 5x to both sides. That way we can keep our x variable term positive. I'm assuming a lot of you know this stuff because a lot of you are not paying attention. Normally I would say add 5x to both sides, but I'm going to make a note down here. Let's keep the variable on left-hand side, okay? I'll show you in a minute. the reason for this. Okay, so I'm going to add 4x to both sides to keep that variable term on the left-hand side. I know it's going to be a little bit more work, but that's okay. These add up to 0. I get my 12 on that side. I get 5 minus 1x. We're adding, so just keep the inequality sign the same. Then I'm going to subtract 5 from both sides. So I get negative x. We're subtracting, stays the same. 7. I do have to get rid of that negative sign, right? So I could either multiply or divide by negative 1. Divide by negative 1. And I get x and negative 7. What happens to my inequality sign? It flips because I divided by a negative number. And I get x is negative 7. Now, I could have worked this problem where I got the x's on the right-hand side positive, and I wouldn't have to worry about flipping any sign or anything, but I would have ended up with this. Negative 7 is greater than or equal to x. It's the same thing, it's just completely flipped, right? This is I've seen a lot of students make just really bad mistakes using this. Try to get that variable on the left-hand side because it's just we as human beings are taught to go from left to right. Okay? So try to keep that variable on the left-hand side. If you end up with something like that, flip it so that the variable's on the left-hand side. All right. Here's my negative 7. I want 1 greater, negative 6, and 1 less, negative 8. Because when my variable is on the left-hand side, I can just follow my arrow. Okay, it's going to be a bracket, but the equal sign. And I'm going to go this way, follow my arrow, and it's going to go negative infinity. Much easier than trying to say negative 7 is greater than x, and I don't know which way to go. Okay, my interval, my smallest number represented in this graph is negative infinity, always get a parenthesis. My largest number is negative 7, and that is included, and there's a bracket there. There's my interval notation. Questions, comments, concerns? Let's try something just a little harder. You ready? If this catches your attention. Compound inequalities. All right, compound inequalities. What do you think compound inequalities means? You have 2 or more, right? In this case, we're only going to do 2. We have 2 inequalities, hence the word compound. Now, I'm going to try to make this as easy as I can. When you see the word and, that's dealing with a less than or less than or equal to. Okay, so the sign, less than or equal to. That's and. So in this problem, we're dealing with an and problem. Okay? Your and graphs are going to look something like this, where you're either going to have parentheses or brackets, and it's going to be in between. The numbers, okay? The word or, what do you think or is going to be? That's right.
Number.
Greater than or greater than or equal to. Are you not paying attention? Your or graphs, 90% of the time, are going to look like this. Parenthesis or bracket, going out to infinities. Be negative infinity, and this would be positive. 90% of the time. 90. Well, what about that other 10%? Well, it could, 5% of the time, it could look like this, where you have parenthesis and bracket going out to positive infinity or negative infinity. And then you have another bracket or parenthesis that goes over that. Okay? So that's 5% of the time. The other 5% of the time, you could have a bracket or parenthesis, in this case going to negative infinity or positive infinity, and another bracket or parenthesis going towards the other infinity. In this case, what's your answer? Everything is shaded, right? All numbers. This is going to be all. So you have to be a little careful with the ors. Kind of like not paying attention to it. All right, compound. That means we have two inequalities to solve every problem. Okay, now if it didn't say and inequalities, you would know that because we have less than or equal signs, right? This is an and problem, so I'm expecting it to be an in-betweener. All right, I have to solve for t. So I'm going to solve this inequality, and then I have to solve this inequality. And since this is condensed and not separated, I'm going to do it all at once. Okay, I have to get this t by itself. So I'm going to add 8 to all sides. So look at this inequality. I have to add 8 to the 10. Looking at this inequality, I have to add 8 to the negative 2. You with me? Huh? Negative 2 plus 8. I feel like I'm talking to myself. 6. Less than or equal to. These add up to 0. I get my 3t. Bring down to my other inequality. Add 8 to 10. I get 18. How you doing, Natalie? Wonderful. Okay, I have to divide this t by the coefficient 3. I have to divide 6 by 3. And then I'm going to have to divide 18 by 3. Okay, 6 divided by 3, 2. I'm dividing by a positive number, so my signs stay the same. These cancel the 1. 1 times t is just t. Less than or equal to 18 divided by 3 is 6. With me? All right. When we go to graph these, I don't care where you put the 2. I don't care where you put the 6. Just pick a bar. What I always say. Pick a bar. Okay, this is going to be in between, so my brackets or parentheses are going to be facing each other. In fact, do I have a bracket at 2 or parentheses? Bracket because of the equal sign. Do I have a bracket or parenthesis at 6? Bracket. And it's going to be a betweener. In fact, that's my interval. 2, 6. Should we do another and, or should we do an or? Yes, ma'am. Not on compounds. Compounds are a little different. On single inequalities, linears, you could just follow the sign. When you get to compounds, it doesn't. Yeah, you look with compounds. You're going to have to use this guide. Okay. That'll be. All right, let's do another and, just to make sure, and then we'll do an or. Okay, I'm going to kind of go through this quick. I'm going to add 3 to all sides. Negative 12 plus 3. Negative 9, be careful. 3x. And 15 plus 3, this one is 18. Okay, divide all sides by 3. Now, this is a case where I'm dividing a negative number, but I'm dividing by a positive, so I do not, repeat, not flip the sign. 3's cancel, I get my x. 6. Okay, pick a bar, put a 3. Pick another bar, put a 6. It's an in-betweener. This one has a bracket. 3 has a bracket. The equal sign. The 6 has a parenthesis. And it's an in-betweener. Let's do some ors. Now, ors, I'm expecting them to go opposite 90% of the time. Okay, this one's actually, they're not condensed. You can't condense or problems, so you're going to have to do each one separate. But in algebra 2, you only have 2. You can only have 2. You can have infinitely many because you can have infinitely many variables. All right, add or subtract 3 from both sides. So I get 2x less than 2 divide both sides by 2. So I get x is less than 1. Or solve the other inequality. Add 7. Did I lose it? Okay, I've got 2 inequalities to solve. Okay, so this one I solved. I got x is less than 1. Now I'm solving the second one. Adding 7 to both sides. So I get 4x greater than 16. And I got to divide by 4. And I get x greater than 4. All right, pick some numbers here. 1 and 4. See, they're both going to be parentheses, and they're both going to be facing out, right? It's an OR problem.
Oh, wait.
Okay, this way, going to positive infinity, you don't have to put the infinity signs there. I like it. It really doesn't matter to me. Okay, now we've got interval notation. We got to represent both of these. So on this one, I have my smallest one, negative infinity, comma, goes to 1, and that's a parenthesis. On this one, I have a parenthesis 4, and that goes to positive infinity, parenthesis. Now, I want to be able to represent both of these. Okay, so with ORs, everybody remember the union symbol? That's what we're going to use. What? Let's do another one. Because ORs are a little bit more complicated. Let's do 13. Okay, I have to solve each one of these separate. Okay, I'm going to subtract 7, go to 0. I get negative 2x less than or equal to negative 4. Divide by the coefficient negative 2. I'm dividing by a negative number, so my sign's going to flip. And negative 4 divided by negative 2 is 2. Or, I'm going to subtract 5 to both sides. I get 3x going to be less than negative 3. I'm going to divide both sides by 3. Hey, no hopping in the classroom. X is less than, now again, don't forget, negative 3 divided by positive 3. We're not going to flip the sign because we're dividing by a positive, negative 1. So put the smaller number down here, negative 1, the larger one up here, 2, and let's see, bracket on the 2, going to go out to infinity, and a parenthesis on the negative 1, and that's going to go to negative infinity. So my intervals, negative infinity to negative 1 parenthesis, bracket to positive infinity, and don't forget the union symbol. It's a lot to go over.